We got a 2015 Honda Civic. It's got a hybrid. Now, I'm gonna be honest, this is not gonna be a fixed video for today, but we're going to thoroughly diagnose this car and see exactly what's going on and what it needs. The AC is not working. And one of my other videos I've done in the past before, I have diagnosed Honda Civic, but it wasn't hybrid, so this is my first one I'm diagnosing, but it has the same or very similar systems. There's a thermostatic sensor on the compressor that needs to be acknowledged by the climate control unit. Climate control unit also needs to see viable pressure in the AC system. Currently it has 99 psi. I'm going to show you that, but those are the two confirmations to grant access for this unit to work. I have the gist of it, but I don't have every single bit of knowledge, but I do know, based off of what I've experienced before, how this system's supposed to work. So I'm going to show you the code, show you that there's no AC operation, and we'll do some basic tests. So again, let me show you that we do have 99 psi or pressure in here. Now I'm going to try my absolute best for those who don't have all this bidirectional scan tools to diagnose this in case you have a problem, but you can't work on these cars without having these bidirectional scan tools. But I'm gonna try my best, so I'm gonna cover those bases too. So bear with me, just try to watch the entire video and we'll go through there. So I'm gonna shut up because I talk a lot. Let's jump into it. All right, for starters, what needs to happen, we have the AC on right now. Compressor's not working, so I'm gonna turn it off. I'm gonna hit it again, and we're gonna go out there and see if we have any compressor operation. So if we look down at the compressor, the clutch isn't working. You can see the bulges on the face of that AC clutch. They're not rotating, so which indicate the compressor's not operating. I hope I can get, there you go, so we can see that the clutch is not working. All right, just take a regular gauge here. It does have pressure. Most systems will work when it's over about 40, 50 psi. Most of them will, but typically, just to be on the safe side, see if you can fit the whole can there. Usually it'll hold about 60 psi pressure. But so we know that it has pressure, so we can negate anything pressure related mechanically, but the computer needs to verify that it does have pressure. So this is where the bidirectional tool come into play. So again, we have no compressor operation. Let's go to the scan tool. So scan tool, we're going to do acknowledge the VIN here, just get logged in. And what I will do is go to the PCM on this vehicle. The PCM is what controls the AC, but you do have HVAC module PID data. Let's go to diagnose. Let's go to control unit. Let's go to, we got to go to body control module, because the HVAC for this vehicle is going to be located in the body control module. Go to body control module, and we're going to go to HVAC. That's where this module is going to be located. Honda is a little slow. So we verified that there's no compressor operation. We pushed the button, nothing. We got Freon in it. Let's go to HVAC. Let's go to codes first. See if there's any codes. So we got B2992 and open in the thermal protector circuit. That's the thermal protector. So I was looking for that word. That's why I call it short circuit breaker. So we got a code there. Now on the live data, so the AC pressure switch thermal protector is off. We need that on. And just to give you the gist of how that works, it needs to have a backfeed of voltage. So this unit sends out 12 volts to one side. It needs to loop back around and receive that 12 volts for confirmation. And that's what grants this system the access to work. Why do I call it AC pressure switch? Am I wrong? Thermal protector? Maybe I meant it's a pressure switch. Well, I don't know. I call it circuit breaker pressure switch. I always thought it was a circuit breaker. Am I? It's probably like an on and off switch. Either way, it probably needs pressure to activate. All right, call me crazy. Anyway, let's move on. So it's a pressure switch. If the circuit is open, it's not going to work properly. So if there is potentially inadequate pressure, or if the switch itself has failed, it's not going to make contact to be able to bridge that voltage to go back. And I'm going to show you what that looks like, and we can test that with a meter. Let's go back here. So we know we got a code. Even if we erase the code, does anything change? Okay, let me follow instructions, because last car didn't follow instructions. Clear the code. Oh gosh, why did you do that? Why would you do that? Why would you give me all that information? Okay, there we go. And now let's see if it comes back immediately. And it does. So this is an immediate comeback. All right, so now what we need to do is check the actual circuit, which is going to be located on the compressor. Again, that need to have a closed resistance, so we need to be able to get a resistance value or a closed circuit. And if we don't, then we need to try jumping the wire, assuming that we got 12 volts. And I'm gonna be honest, I tested part of this already, but I did not test the voltage coming out of this unit. So this is where I'm going to get to ensure that I'm going to condemn this unit being bad and the compressor being bad. So let's go to the AC compressor. Let's check that thermal protector and see if we have resistance coming back. And I'm going to tell you that we don't, but let's go look at it anyway. For the sake of space, I'm just going to pull off this air duct, this cover. There's a 10 millimeter, 2 screws down here I pulled off. Should just come right on out there. Okay, weight it off to the side. Now I can get the camera down there and we can see it a lot better. So we're gonna be at the compressor. I'm using my test light here. It's a 400 milliamp test light. When I prefer the alligator clamp, it's gonna be this. I'm gonna try to be basic, but it's gonna be very difficult because this is not like a really introductory kind of situation. So what I'm gonna do, I have my test light hooked up on ground. I'm gonna poke onto battery positive and see if it illuminates to test my test light, and it does. So what I'm looking for is 12 volts on the wires going through the thermal protector. And now here, these are going to be the wires here. Thermal protector is going to be located on the compressor. So I'm going to pull these wires off. This is the wire going through the thermal protector. These are the wires coming out of our HV AC climate control head. So I should have 12 volts on one of these sources here. So I'll move these wires. So it should be 12 volts on one of these. And there isn't 12 volts. It's not illuminating. Now looking at just verifying, looking at the compressor, that is the only protector, the thermal protector that's on here. This doesn't have any other wires coming to or from it. So what I would like to also do is check the thermal protector, because it's supposed to be a loop system. So if the thermal protector's here, it's supposed to be a closed system. I can check with the ohm meter and see if it has resistance, like 1 ohm, or I can take my test light here, place it on 12 volts, put it inside, pierce this portion, put it inside of here, and ground the other portion, and it should illuminate. That'll be more of a confirming way that it supports a load. So it's grounded now. When I take my test light and ground it, it shorts out, so it recognizes ground. So let's put it in here, and if this is working, my test light should illuminate. Let's just ground the housing. Oh wow, so it works. Before it didn't work. That's crazy. It's working now. So you'd imagine if the thermal protector's working, the system should acknowledge that and work. But I can promise you, when I checked it before, it was shorted out. This is new. I did the same test. So being that it's working, the thermal protector is closed, and now I need, since I don't have 12 volts, well, we might have a problem with our climate control head. And because normally two things just don't happen simultaneously. It's just usually the compressor or the climate control head. The compressor, does the compressor work? Well, that's not a code at the moment. Now, I'm going to say that the compressor does actually function, and I'm going to prove that to you. I'm going to show you that it works because I have a bidirectional tool, and that tool grants me the capability of controlling the compressor. If you don't have a bidirectional tool, what you can do is take 12 volts and short this wire here, and this will cause the compressor to work. All right, the one I'm piercing, and that's if that can be achieved, then you'll be able to see if you get activation. So what I'm gonna do, I'm gonna take a piercing pin, go inside of this wire here that activate the compressor, because the computer should send 12 volts to this to operate the compressor, and we'll see it work. But bidirectionally, I'll also be able to control this and get it to work. So let's do that. I'll take my piercing pin here. I think I can get down right in there, and it should go right through the center. Like that right there. So we should have should be pierced through the wire, and I can just put 12 volts in here and hear the compressor activate. Let me get a jumper wire next. I'm hooked up on 12 volts. Let's see what happens. So the compressor's working. You can see the clutch moving. Cool. All right. So that's how you would check the compressor if you don't have bidirectional capabilities. But just as fast as I did that, I could have logged in and checked the compressor operation. So, oh gosh. So being that we did that, those who have bidirectional tools know this information, so we can move on. We just need to see why we don't have 12 volts on here. And I need to go straight to the climate control unit and see if I have 12 volts coming out these wires here. It should be a blue and a red wire. And if I have 12 volts coming out one of those wires, but not here, then that's a clear indication that we have problems with a broken wire. But if I don't, then there's something wrong with that climate control unit, and we need to replace that control head. You can use a multimeter, just put it on voltage. But I really like to prefer using a test light because it's just so much better. But for the sake of just simplicity, I mean, if it's 12 volts, it's 12 volts, I'm gonna imagine. This battery does look horrible. We're gonna ignore that right now because we're checking for voltage. So leave that right there. Check the meter. All right, so we're good there. We're gonna go down to our wires. These ones here, these are the ones coming out the computer. Look at that. Don't touch it because you could be generating voltage. So we're on the female end. It's not doing anything. Let's move to the male end. It is dancing around. Interesting. Let me see. I'm touching it, but I am grounding it. I am grounded. If I touch it, I do change it a little bit. That's interesting. So what I think I should do is probably like a wiggle test. Take a test light, hook it up to, I can take the male end, the alligator clamp end, hook it up on that male side, and then take the probing end, put it on the ground side, or put some bridging wire in between here and move the wire around and see if the test light illuminates, because it might be a broken wire somewhere that we're dealing with. That fluctuation of voltage is pretty interesting there. Let's go down here on the, right there, and put it right there. And what I could do, just move the wires around, the wiring harness, and see if it comes to places where there's heat and vibration. Or I can, oh gosh, go to the sub harness, like right where it plugs in. I gotta get under the car and get all that. So I'm gonna move all those wires around. I probably should jack it up and check that sub harness first. Let's do that. Okay, here we go. I have a jack standing here, so don't panic. So we're right here at the back of the compressor. There's a sub harness here, and what I would like to do is pull off the connector that's going to the thermal protector, and that's going to the control side of the compressor, and see if maybe the issue is going to lie between here with the connection. So we're right here at the main harness. This is the sub harness going to the compressor, and I'm just going to check for 12 volts, because one of these should be illuminating, capability of illuminating. What probably wouldn't be a bad idea is if I took my multimeter and check the voltage again. Go take my piercing pin, go in there. So we still have the dancing voltage. Let me show you what that looks like. We're on that N pin. So still dancing around. I really think it's just worth going straight to the climate control head and checking the voltage coming out of there, because we're on the red wire. If that red wire at the climate control head should be dancing around like this, and if so, the climate control head is going to be the problem, because dancing between 1 volt and 3 volts, not keeping constant 12 volts. Now we could, I just don't think we're going to be. I don't think there's going to be a broken wire, and the reasons being, if it was a broken wire, it'd have steady voltage. It's not going to be dancing around like that. I just don't see that. felt around enough to get these screws, but I didn't. Directions weren't. I mean, I saw the screws in there, but they're tucked away. That's fine. I'm supposed to take off this fascia for the instrument cluster, but I'm gonna see if I can get away without having to pull that off. So there's some screws here. Labor time to replace the climate control unit is supposed to be 0.7 hours. So hopefully I can get this out with just taking these out without taking the fascia off this right here. So there's some more. Where is it? Gotta get that one and that one. So I get those two. I should be able to pull it all the way out because we already got those two. I heard it relax. So we're in good shape. So when we get back here, I'm going to have to pull up some wiring diagrams and make sure I'm on the proper blue and red wires. Now, the red wire is the main one I should be checking, but what I could do is probably jump on to another voltage source and jump it, see what happens. But we'll see. We need to check that red wire first, and if we have voltage there, then we need to check for a broken wire. If it's still dancing around, let's see what happened when, you know, I jump it with another source because it's broken. There's nothing that can happen, and see if the AC system or that thermal pressure switch gets an okay to operate. All right, come on, you gotta come out now. I got all of you out. Yes. All right, cool. Let's see what we're. Uh-oh. Darn it. We're at the climate control unit. Where we need to be is on pin number 30 and 31. We need to be on the blue, I want to say 31 wire. And that right there is what supplies to 12 volts going to the thermal protector. And next what I'm gonna do, I'm gonna find me a ground. I got my test light here. I can go to, I need to figure out what's gonna be a good 12 volt source. I can test it from here. There we go. So we're right where the cigarette lighter was that we pulled out, just to make sure my test leads are fine. And the 31, let's pull it out so I can inspect it. 31, 30. Does it have any numbers on the back of this? 31 and 30, blue and green. There it go. So there's the blue and green right there. So it's 32 pins on here. 30 and 31. We need to be on the blue. And we need to see if that blue is producing 12 volts or not. Let me get my piercing pin and I can get connected to it. And there should be some numbers on there. Yep, I can see them. They're very faint, but there's 30 right there. So there's 30 and 31. Let's hook up on 31 with the test meter, and we got a good ground source, which is right here for our cigarette lighter. So we can use that as a good ground to test this for 12 volts. I could use a T-pin, but I'm going to tear right into this wire. With the blue, if I can get it on there. I guess why peek outside the house when you just go straight in, right? Whatever that means. Let's see, let's go in there. All right, we got a test meter. I'm on my ground right here at the cigarette lighter. I tested it already, and let's see what happens when well, what do you know? Check that out. That means the unit's broken. Something wrong internally here. Let me see if I can do a peak hold. There's nothing changing. All right, let's try one thing. Let's find a 12 volt source, such as a cigarette lighter, and jump the other wire. See if our state changes. So we need to go to the neighboring one, which is going to be that green. I can hook up over there. It's red. There's green. I'm gonna go straight through the center. And let's take, I would feel better using a test light, honestly. But then again, the unit's broken. It's broken, it's broken. Let's go with this here. I got my alligator clamp. This is 12 volts. I'm gonna hook right up on the white wire here. And let's see what happens. The thermal protector has not changed its state. Let's clear the codes. Just to be on the safe side, let me check for 12 volts. I'm gonna hook back up on the ground here. Zoom out since we already got an idea. Hook up back up on the 12 volts, and I'm gonna check for 12. Yes, I have 12. It's actually 14. I have 14. But the AC thermal protector state hasn't changed. And I'm on the neighboring wire. Maybe it needs to see 12 volts on, well, I'd imagine that one, the green one, because the 12 volts, this one has voltage, the blue wire coming out. But why not just swap them and see if anything changes? Let's do that. Because this is defective. Yeah, nothing has changed. Yeah, it's still not working. Let me clear the codes, because I'd imagine, let's see what happens. I'm gonna tear into this wire again. Okay. Test for voltage. Alright, let's clear the code out and see if anything changes. Erase codes. No, the engine's not off, but let's follow instructions. I got the engine off. Key on. The codes are erased successfully. Let's see if they come back. Yeah, it's opening the thermal protector still. Let's just maybe I need to jump both of them simultaneously, because I mean I have voltage going back in, but maybe it has a reference voltage going out too. I guess it's worth a try, right? All right, I got another jumper wire here, and I'm going to check for voltage. It is a live 12 volts, and I'm going to pierce that blue wire. Let's see if I can see it there. Start the car up. I don't. Checking the codes again. Code is still present. Yeah, the status of that thermal pressure switch has not changed. So I tried jumping both of the wires and nothing happened. And I do trust my wiring diagram because they do reflect the current locations of these wires. So we just simply need a unit here. That's all it is. All right, let's get all these live wires out of here. So unfortunately, the compressor did not work after trying to emulate a signal from an external source to the climate control unit. Now again, me testing the compressor is completely irrelevant. I don't know if I mentioned that, but I think I did. It would have been no point just testing if I had activation to the compressor, being that there was no request or confirmation that the compressor should work. So we've been chasing our ass, gotta stay on a straight and narrow path when diagnosing these cars. Customer only paid for the diagnosis for this, so we have to wait for parts to come. I am going to do a part 2. She wants this car fixed, so more than likely today is Sunday. Monday, I'm going to order parts from a used facility from Keystone, and I should be able to have it. So the video should be out by the end of the week, and we'll do a back test and see if we actually have voltage coming out, since I'll have the unit already pulled out. Other than that, oh, let me get this because I would have forgot. Other than that, this is the same testing procedure as I did with the other Honda Civic, with some differences, but for the most part, there's confirmation wires and there's confirmation components. Things need to happen to grant access for things to work. You don't necessarily need a bidirectional tool to be able to achieve this. However, you do need one to be able to extract codes, because without knowing what the climate control unit or HVAC unit isn't satisfied with to operate and to be able to analyze PID data, I wouldn't have been able to know how to tackle this, because people would be checking relays, checking fuses, checking for operation at the compressor and all, a lot of miscellaneous stuff. You've been chasing your ass. So it's no point of having no bidirectional scan tool when all that stuff is needed to be able to check these newer vehicles. Got to have factory service information. I pay for Identifix. Identifix give me an overwhelming amount of information when it comes to wiring diagrams, technical service bulletins, if I need those. But for the most part, diagnosing is cut and dry. Isolate the problem and identify it, replicate it to confirm that you need to replace it. That's diagnosing. Let me know if you would have done anything different. I love feedback from people. Would you have jumped those wires like I did, even though you were kind of on the fence about what happens to what? Would you have did the same thing I would have done? Would you have replaced the compressor? Would you have replaced the climate control unit? I mean, I like feedback. I don't mind reading what other people say, so I can probably, you know, use something else in my arsenal when it comes to diagnosing. I'm always willing to learn. But hey, look, if anything happened, I'll definitely update. Just be sure to hit that link, subscribe to the channel, stay informed, have a reassurance of my work. See you on the next one.